Hello and welcome back to MetaMath. In this video, I'm going to be covering problem 23 from the 2020 AMCA test. If you're interested in seeing solutions to the rest of the problems from the 2020 test, please check out my playlist, which I'll be linking in the description below. With that out of the way, let's dive right into the problem, which reads as following. 5 different awards are to be given to 3 students. Each student will receive at least 1 award. In how many different ways can the awards be distributed? So after reading the problem, we can tell immediately that it is going to be a combinatorics problem because we're giving 5 awards to 3 students. Furthermore, because of how the problem is worded, specifically the phrase at least 1 award, it indicates to us that we may want to use the strategy of complementary counting. So complementary counting is counting the opposite of what the problem is asking for and subtracting that from the total to get what the problem is asking for. So the opposite of what the problem is asking for would be counting the number of ways in which at least one student gets 0 awards, and then subtracting that from the total. So the idea behind complementary counting is, suppose bad represents the number of ways that the problem does not want us to count. If we subtract it from the total, we get the number of ways to accomplish what the problem is asking us for. So we can go ahead and apply this to the problem because we can start by counting the opposite of what the problem is asking us for, and that's the number of ways in which at least one student, gets 0 awards. So let's say our awards are labeled as follows: Award 1, Award 2, Award 3, Award 4, and Award 5, and same thing for the people, person 1, person 2, and person 3. Let's start by assuming that person 1 get 0 awards. How many ways can we give the rest of the awards? Well, if person 1 gets 0 awards, then each award can go to the 2 other people who don't necessarily have 0 awards. So we have 2 to the 5th power of ways to do that, because there are 2 people who can get each award, and there are 5 awards. However, there are also 3 choices for who gets the 0 awards, so we multiply this by 3 because person 2 could just as easily get the 0 awards as person 1. However, this overcounts the fact that 2 people could get 0 awards. So suppose person 1 and person 2 gets 0 awards. In this case now, person 3 has to get all the awards because all 5 awards have to go to him. So in this case, there's only one way to give the 5 awards to one person, but there are still 3 ways to choose who gets all 5 awards now. We subtract this from the total we just counted because this is overcounted in our total here. One way to think about this is using a Venn diagram here. So suppose we have each circle that represents the number of ways. We can have person 1 getting 0 awards, person 2 getting 0 awards, and person 3 getting 0 awards. When we calculate the 3 times 2 to the 5th, what we're really doing is we're adding up the areas of each of the large circles. And as you can see here, there are some areas that get counted in this overlap. And I'll shade these in a different color to show that this area of overlap, specifically right here in blue, is what we need to take away to accurately count the opposite of what the problem is asking us for. To count for this overlap, we subtract the 3 times 1, which is each of these blue regions. And I'll choose another color to show specifically what we're subtracting away. We're subtracting away, again, each of these regions right here. And now we haven't overcounted anything. We should be careful though because of this region in the middle, specifically right here. If this value was not 0, we would have to add it back because we've subtracted it 3 times and we've added it 3 times. So it ends up not being counted at all. However, we don't have to add anything back because this value should be 0 in this problem, since if all 3 people get 0 awards, it would be impossible to distribute the 5 awards to the 3 people. So therefore, the total number of ways in which at least one person gets 0 awards is 3 times 2 to the 5th plus or minus 3 times 1, which is simply going to be 96 minus 3, which is going to be 93. Now, if we go back to our strategy of complementary counting, we have to remember to subtract this from the total because this is the opposite of what the problem is asking us for. The total number of ways to distribute the awards without any restrictions is 3 to the 5th power because each award can go to 3 people and there's 5 awards. 3 to the 5th is 243, so 243 minus 93 is going to be 150. And this is what the problem is asking us for because this is the number of ways in which every student gets at least 1 award. No student gets 0. So our answer to the problem is B, 150. Now, if you found this video useful, please consider subscribing, liking the video, and dropping a comment down below if you have any other topic or problem you want me to cover. Thanks for watching.